In the beginning of this unit, we reviewed trig to help us find missing sides and missing angles, right? The reason we reviewed that, because it was a review, that's something you already knew how to do from geometry, is because we are now going to be putting these triangles on a coordinate plane, which is also technically a part of our unit circle, okay? So today we're just going to talk about what those ratios are on a coordinate plane. So if I were to have a triangle here in quadrant 1, so let me draw a line here to create a right triangle. Okay, the value of this portion of the line down here is going to be found by however many units it has moved right on the x-axis, right? So this is the x value. While this side of my triangle is however many units it moved up on the y, right? So this is some y value. And then right here, this part of your line, your hypotenuse, is what it would be called in your right triangle, is going to be your r, okay? This is the radius, okay? We are calling it the radius because if I were to draw my unit circle around here, right, that would be the radius of my circle, right? We also talked about referring to a radius within our triangles. If you guys remember in geometry, when we solved regular polygons, we would have the apothem and the radius. We use that 1/2 apothem times perimeter formula. All right, so whenever we are talking about our ratios for trig, for sine, cosine, tangent, or their reciprocals, remember cosecant, secant, and cotangent, your y is over here, right? And this is our angle. If we're on the unit circle, this is my theta. So y is always going to be opposite from theta, right? Even if I were to draw my right triangle over here, right, y is still over here and my theta is still here. So y is always our opposite side. So y is equivalent to being the opposite of theta, which means x is always going to be our adjacent side. Good. And r will always be our hypotenuse. Okay? So it says for a given value of theta, your ratios would be y over r. What's y over r going to be? Opposite over hypotenuse, which is sine. And then we've got the ratio x over r. What's that one going to be? Cosine, because that's adjacent over hypotenuse. And then we've got y over x, which is opposite over adjacent, which is tangent. It says these are constant because of similar triangles, thereby satisfying the requirement of a function that for each x value, or in this case is our theta, right, down here, there is only going to be one y value. If we're making a right triangle, each x value has some corresponding y value. So here are our trig functions. Okay, so we need to get in the habit of referring to, instead of opposite, we need to refer to it as the y value, because if it's on a coordinate plane, it is our y value, right? Your hypotenuse, you need to get in the habit of referring to that as r, your radius, because on our coordinate plane, that's what we're going to be calling it. And then for our x, that's always our adjacent side. So instead of calling it adjacent, we want to call it x, all right? So you guys already told me what sine, cosine, and tangent were when they listed them up above for us. Now a reminder that cosecant is just the reciprocal of sine, right? So instead of y over r, it's now r over y. And then secant is the reciprocal for cosine, so we flip x over r over to r over x. And tangent, we flip over to make cotangent of x over y. All right? Okay, flip it over onto the back. Okay. It says if the terminal side of theta is in standard position and passes through the point P, draw theta and find the exact value of the 6 trig functions of theta. Okay, so they want us to draw a triangle, like what we just drew on the front, but they said that the terminal side ends at this point here. Okay, well this is our x value, and this is our y value in a coordinate, right? So this should mean I'm going over 6 units and up 8 units, right? Okay, so over 6 units might put me somewhere in here. And then up 8 units probably puts me somewhere right about here. Okay, and that's the terminal side of my angle. So remember, your terminal side of your angle looks something like this, right? And we said theta should be this angle right here. So here's my theta. Okay, so we went 6 units to the right and 8 units up. All right, and we can easily find the hypotenuse, r, by doing what? Pythagorean theorem. This is actually a multiple of one of our triples. What could I simplify 6 and 8 by? 2. And if I did, those would be 3 and 4. So what's my hypotenuse? 5. It's just a multiple of 2, so 10, right. Okay. All right, so now I need to give all of our ratios. So we're going to have to give sine, cosine, tangent, and we're also going to have to give the reciprocals, cosecant, secant, and cotangent. All right, so here's my theta down here at this angle. So what is my sine ratio?
Y over R.
Right, y over r, which in this case is going to be
8 over 10.
good. And 8 over 10, will that simplify?
4 over 5.
All right. Okay. What should our ratio for cosine be?
6 over 10.
Very good. Which also simplifies, right? That one would be 3 over 5. Okay? All right, and then we would need tangent. Our ratio for tangent should be,
8 over 6.
okay, which simplifies to,
4 over 3.
nice. Okay, and then cosecant is the reciprocal of sine, right? So what would cosecant be? 5 over 4. And what would secant be?
5 over 3.
Nice. And cotangent? All right. Okay, so this shouldn't be too different than what we were already doing. We're just putting on a coordinate plane, and we're calling opposite and adjacent x and y instead of opposite and adjacent, right? Okay, all right, I want you guys to try those next 2 examples. Or sorry, the next example, and then you can try answering those last questions if you can come up with something, and we will share our answers for those in just a moment. So I'll give you a second to try that next one.
could be wrong.
This is R.
-4 squared.
Anything else can be negative. It just, it all has to be right. No, it just can't.
Yeah, b squared.
Like, so you can go this way, so this can be negative, and this can be wrong.
You can't have a negative almost
Like this line.
Yeah. Because if you don't like b squared, you know the trick seriously.
Makes sense.
Same answer.
Okay, so let's take a look at number 2. On number 2, my coordinate point was -4, 2 for my terminal side, right? So I went, because it was -4, to the left 4 and then up 2. So left 4 would be right about here, up 2, maybe right in here somewhere. Okay, and then I would need to draw the terminal side of my angle. So it looks something like that. So here I've got -4, here I've got +2, and there's my right angle, right? And here's my theta. All right, in order to find sine, cosine, cosecant, secant, we're going to need hypotenuse, right? And how could we find that? Pythagorean theorem. Okay, so the side that I'm missing is the hypotenuse, so that's like my c². So this is the side we call the radius, right? Okay, so this would be 2 squared plus -4 squared equals r². 2 squared is 4, and -4 squared is 16 equals r². And 4 plus 16 is 20. And I need r, so I would take the square root. Okay, there is no perfect square root of 20, but I could simplify it, right? What does multiply to give me 20 and has a square root? 4, right. So the 4 has a square root. The square root of 4 is 2, okay? But the 5 does not, so the 5 stays behind, right? Okay, so our radius is 2√5. Okay, now I just need to substitute that information in for my ratios, right? So sine is going to be opposite, which is the y, and our y is 2, good. 2√5, But we can't leave the √5 in the denominator, right? How do I rationalize? Multiply by √5. So in the top, I would have 2√5, right? And in the bottom, I end up with 10. Okay? Now, cosecant is the reciprocal, right? But if I flip this one over, then I have a radical in the bottom again, right? So I'm going to actually flip over the original, right? So I'm going to have 2√5 over 2. Would that simplify? Yeah, what's going to happen?
It'll just be squared.
Right, because the 2's divide out. Yes?
Add that to square root of 5 over 5.
Yes. Yeah. So we are going to want to simplify, and I kind of ran out of room here. Let me make that a little smaller. So 2√5 over 5. Sorry, oops. 10√5 over 10. There we go. Okay, and then he said you can simplify the 2 and the 10, right? So that leaves us with √5 over 5. Okay, and then we're going to flip this one over, the 2√5 over 2, but here my 2's divide out, so I'm left with √5. Okay, what would our ratio for cosine be on this one? -4 what? Okay. And then we would rationalize, right? So I'm going to end up with -4√5 over 10. But then that simplifies. What's that going to simplify to?
-2√5 over 5.
Nice. Okay. And then the reciprocal of this one would have been 2√5 over -4. And that's going to simplify to?
-√5 over 2.
Nice. Okay, and then my tangent, what would tangent be? Good, which simplifies to nice. And then cotangent would just be nice. Okay. All right, so let's look at this last question here. It says determine which functions are positive in each quadrant. So before we answer 3, 4, and 5, let's take a look at our coordinate grid over here. Okay, well, if I were to draw a right triangle here, we already talked about how this part is x, right? And this part is y. In that quadrant, are the x and the y both positive? Yes, okay. So x and y are both positive, and the radius is always positive because that's distance, right? Okay, so if all three things are positive, which ratios are going to be positive here? All of them, right. Okay, so here, all of them are positive. Okay? All right, in quadrant 2, if I were to draw a right triangle here, is x positive in this quadrant? No, x values are negative because we're going in the negative direction. What about the y value? Is it positive? Yes, okay. So here I'm going to have a negative x and a positive y, and of course the r stays positive since it's distance, right? Okay, so only the x value becomes negative. That should mean it's only going to affect the ratios that have an x in them, right? Okay, so which ratio would that be?
Sine and tangent.
Right. Okay. Sorry, not sine.
Not sine? No, cosine.
Cosine, right, because cosine is going to be our adjacent, yeah. So cosine is going to be negative here, right? And tangent also has an x in it, right? So the only one that's going to have both positives, y and r here, would be sine. So here, sine is positive only. Okay? All right, in quadrant 3, here's my right triangle. We already stated that the x is negative here. What about the y? Also negative, okay? So here, both x and y are negative. Okay, so sine would have a positive r but a negative y. So that'd be negative, right? Cosine would have a negative x and a positive r. So also negative. But tangent would have a negative y and a negative x, which makes a positive. So in this quadrant, tangent would be positive, right? Okay? All right, and then in quadrant 4, what's positive and what's negative?
X is positive and Y is negative.
All right. So which ratio is going to be positive here then? Cosine. Okay, so we do have an acronym to help us remember which ones are positive in which quadrants. We are going to go counterclockwise just like our quadrants do. You know, they go counterclockwise for 1, 2, 3, 4. Okay, our acronym starts with an A, then an S, then a T, or I should do a capital T probably, and then C. So our acronym is going to be all students take classes. So A stands for all of them being positive, right? Students, S, tells us in quadrant 2 only sine is positive. Take, T is for tangent. In quadrant 3, only tangent's positive. Classes, C, only cosine is positive in that last quadrant, all right? Okay, so now that we know what is positive where, let's see if we can answer these questions. Number 3 says, that cosine and tangent have the same sign. So it doesn't matter if they're both positive or both negative, they just have to both have the same sign. Well, in quadrant 1, do they have the same sign? Yeah, because everything's positive there, okay? In quadrant 2, are cosine and tangent going to have the same sign? Yes. What about in quadrant 3? No, because tangent will be positive and cosine negative, right? What about in 4? Right, the opposite's true, right? Okay. All right, number 4 says they're looking for where cosine is negative and sine is positive. So cosine is negative in 2 places, right? In 2 and 3, but they want sine to be positive at the same time. Well, where's the only place that's going to happen? 2. All right. Number 5 says we're looking at cotangent and secant. Well, cotangent goes with tangent, right? So cotangent is piggybacking on this one. And secant goes with cosine, right? So we're looking, where do these have opposite signs?
3 and 4.
3 and 4. So in quadrant 3 and in quadrant 4. All right.